This will be a short review of fractions, decimals, and percents. Fractions are used to represent parts of a whole, and decimals are simply another way to do the same thing. One application of decimals that we are familiar with is our money system. To start off with some decimal basics, let's talk about the place values. In this example, 0.123456, 1 falls in the tenths place, 2 in the hundredths place, 3 in the thousandths, 4 is in the 10,000th place, 5 is in the 100,000th place, and 6 is in the millionths place. So one key observation is that decimal place values end in th to differentiate them from place values to the left of the decimal point. So we can take decimals and write them as fractions using what we just discussed in terms of place values. Let's try these three examples. 0.2 can be read out loud as 2/10, since 2 ends on the tenths place. So 0.2 being 2/10 is the fraction form, but 2/10 reduces, since the numerator and denominator both divide by 2, reduces to 1/5. So that would be the fraction form of 0.2. The next example, 0.17, can be read out loud as 17/100ths, since our last digit falls on the hundredths place. So in this case, 17/100ths, let's think about if that reduces. It turns out it doesn't, so 17 over 100 would be our final fraction form for 0.17. And our last example here just gives a chance to look at what it looks like to involve a mixed number. So 2.425 would be 2 and 425 thousandths, since our last place value there ends on the thousandths place. And just like our first example, the fraction part here, 425 over 1,000, reduces. Looks like these values both reduce by 25, or if you'd like to take smaller factors and do a few steps, that's fine too. Either way, you will arrive at 2 and 17/40ths as our fraction in lowest terms here. So that is writing decimals as fractions. Another thing we'll discuss before getting into some operations with decimals is rounding. So there are some definite rounding rules, and if you'd like to pause the video and read through these for yourself, please do so. I'll just summarize. When we round, we'll be asked to round to a specific place value or to a certain number of decimal points. Once we know where we're rounding, we basically cut off everything behind it, but with one small detail. We have to either round our number up or keep it the same, and we'll talk through how we know that. That's kind of the second step here, but it basically involves whether the value behind where we're rounding is less than 5 or greater than or equal to 5. Sometimes in words it sounds more complicated than it is, but we'll try a few. And we'll also note here that when rounding, it's appropriate to use the approximately symbol rather than the equal to sign, because after rounding, our number is close to but not precisely the same as the number we started with. So 3 examples. Let's try rounding 3.4532 to the nearest tenth. So nearest tenth implies 1 decimal place. So I'm going to basically cut off everything behind it and then talk about if our number stays the same or rounds up. So looking right behind our tenths place at the hundredths place, you'll notice we have a 5. And 5 is greater than or equal to 5, which means that our number needs to round up. So we will round 3.4532 to 3.5, and that would be rounded to the nearest tenth. Second example, round 20.4362 to the nearest thousandth. So thousandths place in this case looks like our digit is 6, so I'll be cutting off everything behind that. Looking again directly behind the thousandths place at the 10,000ths place, we have a 2. And here 2 is less than 5. So our number in rounded form does not have to bump up. It will just stay as 20.436. This is rounded to the nearest thousandth. Finally, we're going to do some rounding involving a money number, a dollar amount here. We're rounding to the nearest cent. Nearest cent implies we're rounding to the nearest hundredth, or 2 decimal places. So keeping that in mind, the first 9 ends on the hundredth place, so I'll be cutting off what follows. The thousandths place, directly behind where we're cutting, is a value greater than 5, which tells us we need to bump our number up. So 45.39 would be bumped really to 45.40, or $45.40 in this case. So that's a little bit about rounding. I mentioned earlier we would look at some of the operations with decimals, namely adding, subtracting, multiplying, and dividing. So we'll look at a few of those next. Adding and subtracting decimals is much like adding whole numbers. We'll just be careful to keep our decimals lined up and carry our decimal points down to our answer. Another little tip you might use is to give the numbers you're adding or subtracting the same number of place values. What I mean by that is you could add a 0 behind this first decimal to make it feel like it had the same number of place values as the second one. And then we'll just add as normal. So we get 0 plus 4 is 4, 2 plus 8 is 10, 1 plus 4 plus 3, that gives us, for that column, 8. Carry down our decimal point. 3 plus 1 is 4. 1 plus 1 is 2. So in this case, the sum of our two decimals can be described by 24.804, or 24 and 804 thousandths. Okay, let's see if subtracting is any different. Again, I'll go ahead and give both values, both numbers, the same number of decimal places. And we'll subtract 8 minus 0 is 8. 9 minus 7 is 2. 9 minus 1 is 8. Carry down that decimal. And then I'm looking at this as 20 minus 4 to give me 16 out front here. Or if you like borrowing, we could drop that 2 to a 1. 10 minus 4 is 6, and drop the 1. So, in this case, the difference of our two numbers is 16.828. So hopefully adding and subtracting feels pretty comfortable to you, much like adding and subtracting whole numbers. It turns out that multiplying decimals is pretty similar to multiplying whole numbers as well. The one thing we'll have to account for here is what to do with the decimal points. So let's try just setting this up as we would for whole numbers. 5.25 is being multiplied by 3.1. And I'm not going to worry so much about the decimals for a moment. We'll talk about that before we finish for sure. So if we do 5 times 1, 1 times 5, we get 5. 1 times 2, we get 2. 1 times 5, we get 5. Drop down, I'll give a placeholder. 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus 1 more gives us 7. And then lastly, 3 times 5 is 15. So adding, there we have 5, 7, 12. Carry that 1, so we have 6 and 1. So for a brief moment here, it looks like our answer is 16,275. But keep in mind the numbers we are multiplying were numbers close to 5 and 3. So 5 times 3, just a rough estimate, tells me my answer should be close to 15. Definitely not what we see here. So how do we get to that? Well, 5.25 has 2 decimal places, and 3.1 has 1 decimal place. So if we add up the total number of decimal places in our problem, it tells us that our result should have 3 decimal places. So currently, this number at the end, 16,275 apparently, has a decimal point at the end, and we will now swing that decimal point back really 3 places due to this fact here. So our correct final answer as the product of 5.25 and 3.1 would be 16.275. And that's it. So again, much like multiplying with whole numbers, just make sure you account for the decimal points so that you don't get an answer that is far too large or far too small, etc. Dividing also is not too bad. We can utilize the good long dividing skills we used with whole numbers. So let's try out finding the quotient of 93.6 and 4. I'm going to go ahead and set this up using long division. Of course, this can be done on a calculator. You can check it on a calculator. So 4 goes into 9 twice, telling us to subtract off 8, leaving us 1. 4 won't go into 1, so we'll drop down our 3. And 4 into 13, that'll go 3 times. Tells us to subtract 12, leaving us with 1. 4 won't go into 1, so we'll drop down our last value here of 6. Also, while this is happening, I'm just going to make sure to carry my decimal point up just straight from where it was inside the box there. And we're looking at 4 into 16, that'll go 4 times. So finally we'll subtract off 16 and there is no remainder. So in this case the quotient of 93.6 and 4 is precisely 23.4. So dividing can get a little bit more complicated, perhaps if you're dividing a decimal by a decimal, but that gives the basics. And then let's talk about writing fractions as decimals. We started this video really by talking about writing decimals as fractions. So let's end by talking about the flip of that. To write a fraction as a decimal, we basically need to carry out long dividing. So if I'm writing 5/8 as a decimal, 5/8 really can be interpreted as 5 divided by 8. So just like our previous example, I'm going to go ahead and set up some long dividing. And 8 won't go into 5, so we'll go ahead and add some zeros to get us through a little ways here. 8 will go into 50 6 times, telling us to subtract 48, leaving us 2. 8 won't go into 2, but it will go into 20 2 times, leaving 4. 8 won't go into 4. Let's try one more 0 here. 8 into 40 goes 5 times, telling us to subtract 40, and we find no remainder. So 5/8 as a fraction is equivalent to 0.625 as a decimal. And notice that we didn't have to round or anything. This fraction did have a precise decimal approximation. Some fractions, like 1/3, will have decimals that go on and on and on, so oftentimes you'll be told to round to a certain place value. So we are not quite done with this topic, as I did mention at the beginning that we would talk about percents, but to keep this video a little shorter, we'll follow this up with a little tidbit on percents. So please watch that video next, and then we'll try some practice.